Hello and welcome to this video on annuities. We're going to solve a problem that concerns annuities. If you have questions, please write a comment or send me a message and I'll be happy to help you. I hope you enjoy the video. In this problem, we have that Daniel contributed equal deposits at the end of every month for 3 years into an investment fund. He then decided to stop making payments and left the money in the fund to grow for another 2 years. The funding was earning the fund was earning Okay. In this problem, we have that Daniel contributed equal deposits at the end of every month for 3 years into an investment fund. He then decided to stop making payments and left the money in the fund to grow for another 2 years. The fund was earning 4.08% compounded monthly for the entire period, and the accumulated amount at the end of the term was $90,000. We need to do two things. First, we need to calculate the amount in the fund at the end of 3 years. And second, we need to calculate the size of the periodic deposits into the fund. And we need to round answers to the nearest cent. Okay, to work with this problem, we need to identify the kind of annuity we're working with. Because here the payments are made monthly and interest is compounded monthly, then we have an annuity that is simple. And because payments are made at the end of the month, we have an annuity that is not an annuity due. So understanding the type of annuity we're working with first is very important. Now, here we have that Daniel contributed equal deposits at the end of every month for 3 years. So it's a 3-year period. And then he decided to stop making payments and left the money in the fund to grow for another 2 years. We have 2 separate time periods here. And because Daniel doesn't pay any deposit for the last 2 years, there is no annuity for the last 2 years. So the annuity is only happening the first 3 years. Here we have the annuity. Okay. Now, we have that the interest is 4.08%. So that's the interest rate, 4.08% that is compounded monthly, or we have 0.0408, and interest is compounded monthly, so we have that there are 12 during a year, interest is compounded 12 times. So the periodic interest rate is that J divided by M, so we divide 0.0408 by 12. And when we perform that division, we find the number 0.0034. So that's the periodic interest rate, 0.0034. That comes from dividing the interest rate by the number of compounding periods that we have in the year. Okay, so let's keep that in mind. And let's erase here and work with the information we just wrote to solve part A of this problem. Okay, in part A of this problem, we need to calculate the amount of the fund at the end of 3 years. So that's the amount of in the fund at this 3-year mark. 2 more years, so here is after the 5 years. Now, the fund, the accumulated amount in the fund at the end of the term of the full 5-year term is $90,000. And the $90,000 were an amount of money we got to from going with no payments from the 3rd year on for 2 years. And interest was compounded monthly. Then we can treat this amount, $90,000, as the future value of an investment. Call it future value 2, is $90,000 of an investment that, and we don't know the principal value, the value we start with. Here at the 3-year mark, that's the value we're going to find. That comes from taking I equal to 0.0034, the periodic interest rate, and in 2 years, because interest is compounded monthly, there are interest is compounded a total of 24 times. Okay, so the starting value, that's the value that we have here at this 3-year mark. The value of those $90,000 2 years before can be found by doing future value multiplied by 1 plus I to the negative n. So we have 90,000 multiplied by 1 plus 0.0034 multiplied by minus 24. And we can use a calculator to compute this value. If you're using a calculator, you want to type in 90,000, then multiplied by bracket 1 plus 0.0034, and then raised to bracket negative 24. And then you want to click on enter. And when you do that, you get the value 82,959 point, a bunch of numbers that start with 1 and then 2 and then 9, so we round this off to 13. So the answer to part A is right here. The amount in the fund at the end of the 3 years is $82,959.13. Okay, so this first part of the problem concerns interest. We are computing interest, but in reverse, because we have the future value of the investment when we need to find the initial value of the investment. Okay, and it's all about compound interest. Now, the first 3 years we have the annuity to work with. In part B, we want to calculate the size of the periodic deposits into the fund, the deposits that Daniel was contributing at the end of each month. So let's erase what we have here. And we keep that answer to part A in mind. And let's see what happens. Let's see what we use to compute the size of the periodic deposits. Now, the type of annuity that we have, we can say that the after the 3 years, the future value of the annuity is the value we just found, the amount in the fund at the end of the 3 years. So we have about $82,959.13. And for a simple annuity, like the one that we have, the formula for future value is PMT times 1 plus I to the n minus 1 over I, where PMT is the size of the periodic deposits into the fund, I is the periodic interest rate, so we have 0.0034, and n is the total number of payments that are made. Because payments are made every month for 3 years, n equals 12 times 3, which is 36. So we have that 82,959.13 should be equal to the size of the periodic payments, of the periodic deposits, times 1 plus 0.0034 to the 36 minus 1 over 0.0034. So we can solve for the size of the periodic deposits. We take 82,959.13 and divide it by that huge number, 1 plus 0.0034 to the 36, take away 1, over 0.0034. If you're using a calculator, then you want to use the following expression. Let me just move this over a little bit here. So here you want to write 82,959.13 divided by bracket, and then bracket again, and then bracket again, 1 plus 0.0034 to the bracket 36, take away 1, close bracket, divided by 0.0034, and then close bracket. And what we get when we use the calculator to compute the answer to part B is approximately, so this is a symbol for approximately, 2,170.18. Therefore, the size of the monthly payments deposited in the retirement fund was about $2,170.18. Okay, so this is the answer to part B. Okay. So we can summarize what we did in the following way. For part A, we calculated the amount in the fund at the end of 3 years by using compound interest, because money was sitting in the fund to grow for 2 years, and it grew into $90,000 at 4.08% compounded monthly for the entire period. So to answer part A, we used compound interest formulas. Now to answer part B, we used annuities. And there was an annuity. Daniel was contributing equal deposit at the end of every month for 3 years into an investment fund. We have that the fund after the 3 years is about $82,959.13 big. Then we use that money as the future value of the annuity. To compute the size of the periodic deposits of the annuity, we use this formula that applies when we have the type of annuity that we have. Okay. All right. As I said at the beginning of the video, if you have questions, just try to contact me. Either write a comment or contact me in some way, and I will be happy to help you. Thank you for